Hello folks! In this video I'm going to show you how to play with an OpenStack installation integrated with Embrane plugin, building network topologies leveraging Embrane heleos to create virtual routers and load balancers. So we're gonna log in the OpenStack dashboard first. And now we can go around and see and check some configurations. So the first thing we have to see is that our demo tenant just have one private network, and so we may want to add some more for having more interesting topologies. So first step, we create a public network from the admin console. And we also add a subnet on that network. All right. We can also create more private networks. For instance, we can go from the tenant console and add another one. Great. Okay, now we can create our first router, which will use the underlying Embrane plugin to be created. And here the router is in pending create state. Let's see our network topology now. And as we can see, we have basically three networks with a subnet each, and this cool router with no interfaces in it. As a next step, we want to create some instances, but first let's upload a new image in order to create those instances. So we're going to add an Ubuntu image and a QCOW2 format, and so setting some basic parameters, and upload it. Once it's done, we are finally ready to create some instances and finally be able to test our network connectivity. Okay, let's create the first one. At first, we are going to create two instances which will be placed on the private networks, one for each one. And once the instances are created, the DHCP daemon is gonna push the address configuration within them. So Neutron is gonna choose the address to give to those instances, and the DHCP server is gonna actually give the address to the instance. And there we go. Also, the second one is created. And we can finally go and check our network topology now, which consists basically in the same router we had before, but we finally have one instance per private network. Let's go and add some interfaces to the router. So from the router tab, add the interface. We choose the network in which to add the interface. We don't select any IP address, so that the IP address assigned will be the one of default gateway of that subnet. And that's what happens in our network topology. So finally, our router has an interface on one of the private networks. And now we want to connect it to the other private network in order to see if there is connectivity between the two instances. So we do that. Again, we didn't choose an address, so that the router will be the default gateway for those virtual machines. And let's see now if everything is fine on our virtual machines. So we log into them. And as we can see, the IP addresses has been correctly assigned from the DHCP daemon. Let's try to ping the interface of the default gateway, which is the interface of the router we just created, and it works. Let's go now on the other instance, check that everything is fine. And here again, the address has been assigned and we are able to ping the default gateway interface. Let's now try to ping from one instance of the virtual machine to another. And it works. So the router is actually routing our packets and there is connectivity between the virtual machines. Let's now go back on the router control interface and let's add a gateway interface to it. This will put a router interface on our previously created public network, and that's how our topology changes. So from now, we are basically able to reach the other virtual machines from that public network, and the very host from which I'm doing the presentation is actually placed on that network. So we are now going to try and see if we are able to reach that particular router interface. So try a ping. Which works. Okay, let's now go through the address and security tab and allocate a floating IP for one of those instances. So we choose the network from which the floating IP will be taken, and we associate it to one of our instances. Here we go. Okay, from now on, what changes in our network topology is that if an host, for instance, from this network, try to ping that floating IP, the request will be sent to router 1, which will translate the destination address to the one of the virtual machine we are trying to reach. So let's see if this is working. And as we would expect, it doesn't work. Why does it work? Well, this happens because there is another kind of security, which is the security group, which is added by the Neutron plugin. And so what we have to do is to set a couple of rules in order to be able to reach that virtual machine from a public network. Let's set the rules for ICMP and TCP. And let's try again. Now it works. Good. To be sure that we are actually reaching that virtual machine, I'm gonna send a request to that address from my browser. And the web page, which is on that virtual machine, is gonna answer me with the actual private address of the instance, which is the correct one. And let's now go and make things a bit more interesting, for instance, creating load balancers. Okay, so as a first step, we create a pool. We choose the subnet in which the pool will be set, and some other configurations. Here it is. We now go and add a member to the pool. And there it is. Now, of course, it's not going to be very interesting with just one virtual machine to balance the traffic. So let's go add a couple more virtual machines on that network. Okay. The virtual machines have been created. And we can now go add them to our pool. And here they are. Okay, we can now create a VIP for this pool. We choose an address which has to be on that particular subnet, but it's just a constraint added by the OpenStack dashboard. So from the CLI, you would actually choose a different subnet for that VIP, but for now, let's just stick with that. So we set the protocol, the port, and we create the VIP. Good. So our VIP has been created. And now we want to make sure that we are able to access that VIP from the public network. So we disassociate the floating IP we previously gave to the other virtual machine, and we associate it to the address of our VIP. Now, the dashboard is not showing us the changes, but what basically happened is that we have a load balancer placed here, and from the public network, we are able to reach the floating IP we set, which will be translated on the address of the VIP. And the request that the VIP receives on the correct port will be balanced between the servers based on the configuration we set before. So let's try it. And as you can see, refreshing the page, the answer comes always from a different server, which is showing that our balancing is actually working. Good. So our topology is working. Let's now see what happens from the heleos side. So basically, our plugin was able to create a new tenant, which is OpenStack Demo, which is the name of the tenant we had on the OpenStack side plus the OpenStack suffix, and created a router and a load balancer. So we can go and see that all the configuration we made from the plugin has been set on our virtual appliance on the heleos side. So we have a certain number of interfaces placed on certain networks, and also all the rules set to be able to do NAT for the floating IP, and also network configurations and so forth. On the load balancer side, we see that we have our statistics on the traffic received by the load balancer, and also all the members set with their port, their health check, and so forth. So everything is just set as we did from the Neutron plugin. And that's it. This is the end of the demo. Thanks for watching.